General Grievous.
Which one is General Grievous?
The one with the like 6 lightsabers. 4 lightsabers, not 6.
It's 4.
Don't touch your backpack.
So I've heard two different things. Most of the people that have written about WandaVision online say it's horrible. And Miss McCullough said it was wonderful. So I'm trying to debate. One of the reviewers said it was like a nail through your forehead.
Hello.
It's just because you have no idea what's happening. Yeah, you have no
Is that
idea
the-
what's happening.
Okay.
Which adds to the mystery.
I'd say that person's a bit harsh.
Yeah.
I haven't watched any of it yet, so
Whoa, I messed up my calculator. What did you do to it? Did you put it on the wrong mode? There we go. I got it. Wait, I'm gonna code something real fast. What are you gonna code? I don't know how to code.
you're gonna code that I don't know how to code. Then you just type in print, I don't know how to code.
Not print, but yeah.
What's the command for show on the display? Display,
Text.
right? Text, okay.
Well, in the graph it's text. In the menu it's output.
Not output. Output is when it shows a number.
It can be output. You can do output. I'm looking at it right now. I'm doing output.
All right, any questions? Yes.
16.
Let's take a look at number 16.
I don't know. Ben knows way more.
Yeah, Ben's the subject matter expert. He knows more than I do as well.
He told me how to even do
I did.
Yeah, you're the one that spent, what, months playing around with it when you were supposed to be learning math?
Well, yes, but on the contrary, my math scores didn't dwindle, did they?
Well, that one that you had to make up last year.
That one was weird.
All right. Okay, so number 16, we're talking about a jet is capable of a steady climb of 20 degrees. How much altitude would the jet gain when it moves 1 kilometer through the air? Okay, this one's tricky, although they did give you the perfect picture. So the issue with an airplane is that you have ground distance, how much it covers on the ground, you got air distance. So it says at a 20 degree, it covers 1 kilometer. Yeah, 1 kilometer, 1 km. And the question is, how much altitude? So which side is the altitude?
the short side.
Okay, so in relation to this, we have the opposite,
Opposite.
and we have the,
Hypotenuse.
what's the opposite over the hypotenuse?
So it's 1,000 sine 20.
That's sine. So sine 20, I'm gonna leave it in kilometers because it's easier than, oh no, it says the nearest 50 meters, so we do have to convert it to meters. So 1,000, you are correct, all over,
Isn't it
No, x over 1,000.
opposite over hypotenuse, sorry. Okay.
Math mistake.
Again, he claims formatting error, which is cheating.
No, that
Yeah, how dare you?
No. Not a formatting error. It would be weak argument for formatting error. So yeah, you're right. 1,000 sine 20. Whatever that is the answer.
What's the answer? Because I can't see it.
What did you get?
I got approximately 350 meters because it asks you to round to the nearest 50th.
That is correct. What is the actual answer?
It was like 340.
It's 342.
All right, so that'd be 350. Yeah. Yep, that's right. Anybody else? All right, here we go. Number 1, 2 answers for all of these.
There's
Not
two.
all of them. Not all of them.
Up until
7, 8, 9. I was only 1.
up till 12.
7, 8,
9 has 2. There's 2 and 9.
So just 7 and 8.
7 and 8.
Okay. All right, number 1, x is 21, y is 28. Number 2, and these are all approximate. These are all rounded. X is 102, y is 64. Number 3, x is 89, y is 117.
Wait, what? Oh, okay.
Number 4, x is 54, y is 64. Number 5, x is 28, y is 10. Number 6, x is 28, y is 26. Number 7, now we're doing degrees. V is 26 degrees. Number 8, V is 67 degrees. Number 9, one's a side, one's an angle. X is the side, it's 9. And V is an angle, and it's 63 degrees. Number 10, X is the side, it's 9. Nines. V is 42 degrees. Number 11, both of these are degrees. V is 37 degrees. W is 106 degrees. Number 12, both of these are sides. X is 20, Y is 10. 13a says leave in radical form. So it's a square root of 115. B says give me the values now. So Y is 40 and X is 10.7. And that Y should be in degrees. C is a yes. And the second part, are the values of X in parts A and B reasonable? Yes. Why is there a comma? It's just a yes or no.
What if you
And they say,
get so
oh, I get it. Part A, you left it as a square root of 115, and part B, X is 10.7. That's the square root of.
So you're saying it's because of that.
I got it.
So
I didn't even
you
do
have
that.
to decide what works best for you.
Says use Pythagorean theorem to find the value of X in radical forms. I mean,
Same
leave it to
answer,
square root.
right?
For a minute.
Number 14, about 83 meters.
Left or right. But see, you're not always.
I agree, Ben's mom.
All right.
I didn't know I was unmuted.
Number 15, about 149 meters. And we did 350 meters. It doesn't sound, that's 1,000 feet. Doesn't sound very high. In 1 kilometer? You'd think it would go higher in 1 kilometer, but
Well,
oh
it's
well.
only a 20-degree.
20 degrees is pretty darn steep.
Yeah, no, not really. Because it's just taking off. They don't get that high up when they're taking off. But then once they're in the sky,
1,000 feet is not that much. Yeah.
yeah.
Do I need
Yes, you do.
I go get it?
Sure.
Ooh, what are we doing today?
Just one
Applications of right
application
triangle.
of sine, cosine, tangent.
Oh, that's boring.
And it is the most commonly used one. In fact, it's got its own names. And Jack is going to spoil the fun and already learn those names
Tell you the name
before
of
I even ask the question.
Wait, Mr. T, how do I break it?
Jack.
This is so easy.
Didn't say, why did I say this is going to be a hard lesson?
I could do this without even needing to.
All right, 2 days of review. Hey, tomorrow, I'm going to give you the same review as the normal class. So it's just going to be skill based. And then on Monday, I'm going to give you a copy of what the test is really going to look like. What you're really seeing is what their test is going to look like and what your test is going to look like. It's good practice because tomorrow it's just the skills, just the
So many
4 or 5 skills we need.
I mean, not chapter 8, but chapter 9, we're getting a review as well. Is the chapter's getting harder?
Generally speaking, this one is only, I mean, I don't want to say it's hard, but it's just a lot of stuff in this one chapter as compared to the other chapters. And then the next chapter deals with circles, and there's just a lot of things going on with circles. You'll see why when we dive into it and you're like, wait, it's the hourglass one. No, it's where the angle is outside the circle. Oh no, the angle is on the circle. There's just a lot of things can happen, a lot of formulas.
Well, they have it used for my book of truth then.
Yes.
Oh, I see. It's word problems. Word problems.
Well, these are some of the easiest word problems you're ever going to see.
It's also do I have to draw a diagram?
You do, because otherwise you get the angle backwards. And the diagram isn't going to be that complicated. But you're going to want to draw it simply because you need to make sure that you label the pieces parts correctly.
What if I
And
don't
stop
draw?
looking ahead. Or if you are going to look ahead, then be quiet and figure it out yourself.
I am quiet. You told me I have to be quiet for this whole year.
Let's see,
I'm
Is
still
it
waiting
okay
for that
to-
day to happen.
Oh, look. So
Unless we do an algebra review, please.
Yeah, but I'm still waiting for it to happen.
this is the exact same thing as.
I shout out answers.
Yes, it is, except it's got names to it now.
But it all
And I will reveal a very sensitive side of myself that I only revealed to some people of how I screwed up high school math in this one part. And it wasn't until college that I figured it out. All right. Applications of right triangles in trig. Quick review. Remember, we're dealing with trigonometry. At least for the trig that we're dealing with, we will be dealing with only a right triangle. We're not concerned ever, at least for right now. We will later. With the right angle, we're concerned with the other two angles in this particular diagram, A and C. We label the sides. The hypotenuse is always the side that's opposite the 90-degree angle, and the other two sides are opposite and adjacent. We get these three trig ratios, and the way that we remember them is SOHCAHTOA. For this particular trig, we're only solving for side lengths of a right triangle or for angle measurements. We're solving for the side lengths. They give you a triangle, it'll be right. They'll give you an angle, and they will give you one of the sides. The other side will be a variable, or they'll say find out the length of this side. You set this up. You solve for y. Remember, this comes in two flavors. Either the y or the x, whatever the variable is on the numerator or the denominator. It's just some basic algebra to solve for. You're either multiplying by the number, in this case the denominator, times the tan, or when the variable is on the bottom, multiply both sides by the variable. You're dividing that number, in this case 32, by the tan. That's the only way it happens. And by that I mean both sine and cosine as well too. All right. So for angle measurements, I still haven't changed this. That 30 is not supposed to be there. But if you did not know that that was 30 degrees, you would set it up using the appropriate trig ratio, in this case sine, to get the A by itself. That's what we're solving for. You do the inverse of the function of the trig ratio. So the inverse of sine is inverse sine. The reality is most of us learn the pattern, and what's on the right of the equation in red there is what you type into your calculator. Everybody gets the right answer. If you didn't have a calculator and you had that table, you would still do 3 divided by 6, which is 0.5. You'd look under the table. Okay, I haven't shown you this, but you wouldn't look under the table under this. You would have to look where 0.5 was under the sine column and then look to the left to see the actual degrees. I'm not sure why I'm telling you this, because I can't imagine a day where they would make you use a table. I have seen, now this is maybe 10 years ago, I have seen some questions on a test where they will give you a portion of the table. And they will say something like, hey, here's a small part of the table that shows the tangent of 50 degrees is blah, blah, blah. And you will not be challenged by that one, because it'll be just one little part of the table. All right, review's over. Turns out that, well, hopefully I've made it clear that the reason why they show you this is that this particular stuff, trig, specifically trig with right triangles, is one of the most used things that we have. You guys know about GPS, right? Global positioning. How does it work? Yeah, how does it work?
Oh, there's a satellite and like.
What does it do?
It's a satellite and it translates.
What does it do?
Oh wait, all you have to do is watch Wonder Woman 1984.
How does it know where you are?
It can tell you. You have a chip in your brain. Chip in your brain.
It's just a trig. Watch this. Now, it has to actually have at least 3 to do this, but let's just use 1. So you're on the Earth and you're right here, right? Above you, there's a satellite, has a radio inside, and you have a radio, right? Your cell phone's a radio, right? So the satellite sends a signal. Well, it's radiation. Radiation goes in straight lines. So you get this straight line that comes down right here. You get this angle, and basically you're just doing some trig. It's all it is. It's a sine, a cosine, or a tangent to find out where you are. Now,
wait, so I'm carrying a radioactive device.
Radio, not radioactive.
Like as in where you feel like.
Yeah, I know, but he said radioactive.
I did. You said radioactive.
You said radioactive.
I said there is a radio in that.
No, you said the radiation goes into.
Oh, there's radiation, absolutely, but there's 2 types of radiation. One is called ionizing, and one is non-ionizing. Ionizing, that's the one where the radiation is so powerful that it knocks off portions of the atom, the parts of the atom, and it's bad, right? It breaks down your atoms, basically. The non-ionizing radiation is like radio signals, right? And that's the good one. They're actually both good, because you can use ionizing. I mean, if God forbid you catch cancer, but they use radioactive isotopes. They inject it into your body to specifically go to those cancer cells and kill them. That's what chemotherapy is about. All right. I'm not sure how we got on that subject. Oh, it's McKinley, of course. All right. So here's the new idea. Hey, you're standing somewhere,
Who's her?
and off in the distance, you look to the horizon. I look to the horizon, and I see the Eiffel Tower.
Where is this? Why is this? What is she doing here?
She wants to know how tall the Eiffel Tower is.
The fool. The
So
fool.
what does she do? Well, first off, remember, she looks to the horizon first.
I don't think she's that smart though.
Right.
The average person doesn't do
Well,
that.
after this class, everyone will be that smart.
I don't know.
She looks from the horizon, she elevates her eyes to the top, and she says, how tall is the top? Well, clearly, what is she making here?
A
I
triangle.
guess.
A triangle where this particular side of the right triangle is the height of the Eiffel Tower.
Unless you measure it with her eyes.
Well, okay, so there's the part where this particular one falls apart. She would literally have to have a
Okay, you gotta measure it.
protractor with her, but she could measure that.
Yeah,
right?
but she also has to measure the side with her eyes.
Yeah, so that's the interesting thing.
You
So
really
it
think that they're just gonna
turns
let her go
out,
up to the top and just.
that that's not the only thing we need. We need one of the three sides in order to find a second
Actually, you
side.
need two of the three sides if you're gonna put as theta.
We need one side. We also need that angle, right?
Yeah, you need the angle. That's
Well,
what I'm
then-
saying.
Well, you could get that easily with a protractor, but we would need one of the other sides. So it turns out that this construction right here is used so often, we give it a name. Now I'll go back to how it's constructed. She looks at the horizon and she elevates her eyes.
Angle
to the
of
top.
elevation.
This angle that's created, I'll call it theta, has a name to it. The opposite is this. Well, instead of being standing on the ground, she also could be standing at the top. Well, you get a different construction. Once again, she's standing at the top. She first looks to the horizon, and then she lowers. Another word for lower is depresses her eyes down to somebody down there that she wants to see.
Who would that person?
This angle right here has a name. Once again, we get a right triangle. This angle is called the angle of depression. Now, I told you I would bare my soul and tell you how I screwed up in high school. Is I didn't listen to the teacher after this picture right here. I was like, oh, this is easy. I got this. I got that part, but I didn't hear the story about angle of depression. And I'm going to say for all of you, this can be easily screwed up if you don't do one thing, and that one thing is, what did I tell you she does first?
She looks down.
She
She
doesn't
looks
look down.
down. She looks across, then she looks down.
The horizon first.
Yeah, that's down. No, that would be up.
No, that would be that line right there. The horizon is, I said, look at the horizon. You don't look down to the horizon. You don't look up the horizon. You look straight out.
But the
And it doesn't
horizon-
matter whether you're on the Eiffel Tower or standing still. You see two different horizons, but you still, to see the horizon, you look straight out. If you can remember that part, you won't make my silly mistake. I'll show you my silly mistake here in a second. But that has a name. We call it the angle of depression. So box one or your book of truth, it doesn't matter. This construction right here is called the angle of
We
elevation.
don't have the book.
Oh, sorry.
I mean, the thing.
Page.
Sorry.
The thing with the thing with the thing with the thing with the thing. And yeah,
Well,
thing I broke out.
what did I do with it? Interesting.
No, this is the first math book not destroyed by my law.
I don't know what to do with it. You guys just have to write down. All right. Sorry. Angle of elevation is the angle formed by looking up from the horizon. But still, it includes the fact that you look at the horizon first. You're going to look at the horizon first. What did I do with this? Mystery. The opposite of angle of elevation is when I look at the horizon first and I look downward. That is called the angle of depression. And I know why I got in trouble. Look over here. You see where I put the angle here? It would be very easy to also put it right there. And there was my mistake. I didn't listen to the teacher. Because you have to look at the horizon first. it really feels like the angle of depression should be this angle right here. Ben, I'm pointing underneath her picture.
Okay.
And that's not the angle of depression. The angle of depression is above that line.
But who is this lady? Why does she?
I
want
don't
to
know. I
measure?
literally Googled, I don't know what I Googled when I got that picture. But I wanted someone looking straight out. So this is called the angle of elevation, angle of depression. I will just say, I can't think of a single test for geometry, SAT, probably the NWA test you just took. This was probably one of the questions. They said something about angle of depression or angle of elevation. They use this all the time.
Face.
Angle of elevation, angle of depression. Yes, good. All right. It can be. It was confusing to me. It was only confused because I stopped listening to the teacher. And it's usually the angle of depression. So for some people, this can be confusing. Like McKinley, are you a 4 or a 3 person?
4. Yes, 4.
Well, there's 1, 2, 3.
No, there's 4.
No, there's 1, 2, 3.
No, there's 4.
1, 2, 3.
There's technically 6.
What?
Where do you get 6 from?
I am
Are you
correct.
a 4 person or a 3 person?
4.
It's
Oh, there's 1, 2, 3.
4.
It's 4.
4.
It's 7.
2, 3.
It's
4.
I saw it.
There's
All right.
7 logs if you add them all together.
All right. I don't know why math books and math teachers like the sailboat and the lighthouse, but all of these problems will always involve a sailboat and a lighthouse. Why isn't it a power boat? Why isn't it? And it also involve an airplane, right? Airplane in the ground. But it's either the sailboat and the lighthouse, or the airplane in the ground, or occasionally it might be a kite.
I got a kite.
You got a kite. We love those. I don't know why. We're pretty boring. So here's the idea.
We're a rocket.
Both of those, the rocket's fine. I don't see that often. A sailboat, if you're on the sailboat and you look up to the light, is that an angle of elevation or angle of depression?
Elevation.
Now remember, the first thing you must do is what?
look to the
I got to look to the horizon. So the first thing, blue line, is you get that construction. And then you elevate your eye up to the top of the lighthouse if you're trying to figure out how big it is. So that's your angle of elevation. Flip your position. Now I'm in the lighthouse. The first thing you do, and this is why I got it wrong, is because I thought that this angle right here, I pointed to the upper right angle here, Ben. I thought that this angle right here was the angle of depression. It's not. It certainly seems like it should be, though, right? Because I wasn't listening to the teacher who said the first thing you must do is
look to the
I got to look to the horizon, red line. So the actual angle of depression is right there, not right there. That's the angle of depression. It's 2 different triangles. Well, I should say it's 2 triangles that are not the same position. Turns out both triangles are congruent to each other. All right, what can you tell me about the angle of depression and the angle of elevation according to this picture?
They're parallel.
Angles are not parallel.
No, that's a line. It's a line. You clearly made it not line.
What can you tell me about the angle of depression and the angle of elevation?
They're parallel from each other.
Angles are not ever parallel.
Yes, they are.
Angles.
You can make
What?
angles
They're
line.
congruent
Why?
because the red and the blue line are parallel. Because
That part is true. Therefore, they're actually
No, you didn't.
they're actually alternate interior angles. So the relationship between angle of depression and angle of elevation is they're the same.
Cool.
Now, you got to be careful. It's not just any angle of depression, any angle of elevation. It's the angle of elevation to an object is the same as the angle of depression from that object. And it's basically this construction right here. Now, yeah, you make a nice little rectangle there.
I was right though. They are parallel.
The sides of the triangle are parallel, but the angles are not parallel.
But I would still get to the same answer.
I get a year's break from the community. What will happen here? Will I regain my sanity?
No, because he's gonna come back and ruin it again.
Who knows? Maybe McKinley will change next year. He'll stop talking about random things.
I don't talk about random things.
I'm not willing to take that.
Maybe he's
Yes, Ben, I agree.
so sad.
Maybe he'll take chemistry. It will be overwhelming. Mrs. Newburn was grading her chemistry stuff in front of me during lunch. And she was just talking about chemistry. All right. So good job of that, Smart Pants, figuring that one out. Okay, so the problems will all be basically like this. There's going to be two things. Something's going to be up high, something's going to be down low, and you're either going to be talking about the angle of depression or the angle of elevation. And Jack said, why do I need to draw a picture? Because you can screw this up pretty quickly without drawing a picture. So calculate the distance between a sailboat and a lighthouse. If the lighthouse is 25 meters tall, and the angle of elevation, this is the part you got to be careful of, the angle of elevation between the sailboat. So elevation means you're looking up. So clearly, where are we if we're looking up?
On the ground.
So we're on the sailboat. Doesn't say that, but you got to use a little bit of common sense. So if we were talking about the angle of depression, you're on the lighthouse. If you're talking about the angle of elevation, then you're on the lower one, the sailboat. So it doesn't have to be a complicated picture. And by the way, these will always be right triangles. So if you just want to draw a right triangle and just label the vertex as the sailboat and the lighthouse, then that's all of the picture you need. All right, so yes, I have a sailboat. So I'll draw a sailboat. There's my lighthouse. McKinley, how tall is the lighthouse?
The lighthouse is 25 meters tall.
Okay. Do we know the distance between the sailboat and the lighthouse?
No.
We don't. So we will just call that distance.
The line
We will call it
X.
okay. Do we know the distance between the sailboat and the top of the lighthouse? Do we know that?
No.
Okay. If we needed to, maybe we call that Y. But I do know the angle of elevation, 2 degrees. So the question actually reads, what? Does it say how far it is from the sailboat to the top? Or does it say how far is the sailboat from the lighthouse? So are we solving for the top or the bottom? The bottom. So that's my X, right? If you want to put the other side as Y, you could. All right, so what kind of trig are we doing here?
I think scale.
Scale?
Sorry, sit sine.
Because sine is opposite over hypotenuse.
No. But it's just tan.
It's tan. So tan 2 is equal to
25 over X.
because that's opposite over adjacent.
That's like a 12-degree angle right there.
Agreed. Well, I had to draw it. I wouldn't be able to fit the 2 in there if I literally made a 2-degree triangle. So be careful with that for homework because obviously that's not 2 degrees. Remember, pictures are never drawn to scale. Typically, they're just drawn. Until we let's see, what chapter do we draw them to scale? Is that next chapter? Maybe. At some point, we are going to draw things to scale. McKinley, how do we solve this sucker? This is the ugly one.
25 tan 2.
No,
Yes.
this is
No.
the other one.
Oh, the divide tan by tan equal 20 foot tan 25 divided by 2.
They also like to do stuff with
How about we
shadows.
just do the algebra and then you admit that you don't have the pattern memorized?
No, I don't have the pattern.
All right, so what are we going to do first? Both sides.
25.
Yeah, but where it's going to 25 times 25 doesn't get rid of 25.
Oh, to divide 2 on both sides.
You can't do that. 2's on the inside of 10.
Oh,
You remember what you do when it looks like this?
we multiply X.
Both sides by x.
Yes.
And the reason why we do that is because x is the denominator. We want to get it out of the denominator. What happens on the right side?
It disappears.
Cancels. So I'm left with that. Now what?
Now you divide 2.
I don't divide by 2.
Tan 2.
Tan 2. Tan 2's are canceled. Now you grab your calculators. The answer is, how far is the lighthouse from the sailboat?
What the?
Dang it. 25 divided by 10 to
750. 716.
716 rounded? Okay, I'll buy that.
I almost remembered it, so that's the
Almost will get you a D, that's good.
what?
Almost will get you a D.
What?
That's a good point.
Well, it's almost passing.
But the D isn't almost passing, a C would be almost
Well,
passing.
C is passing.
Oh, well,
A D is almost passing.
I'll just write this in.
So
the
if you
book.
almost get it right, you'll almost pass. All right, Ben, questions?
No.
But, right, yeah, I can give you the same problem, just change the words around and you can set, if you set this up incorrectly, you get the wrong answer. So make sure you read it carefully. So tell me the setup there, Ann.
So the lighthouse is 25 meters.
Lighthouse is still 25 meters. This looks exactly like the previous one. It's not. Lighthouse is 25.
And then angle of depression, angle of depression between the lighthouse. So that
What's the first thing I should draw on all of these?
horizon.
Horizon line. So if I draw the horizon line, I can't screw this up. Well, hopefully not. Now you can fill in the other bits of information. So what do you want me to draw now?
Connect from like the sailboat to the lighthouse.
Okay.
And then that's 15 degrees.
Okay. And that is 15 degrees. There's the red. So that's going to be 15 degrees. We know the lighthouse is.
25.
If the lighthouse is 25, then how big is this?
25.
Yeah, because it makes a rectangle. And what are we solving for? The distance between the lighthouse and the sailboat, or the distance between the top of the lighthouse and the sailboat? Two different distances.
Well, you can't really measure from the lighthouse, so.
We can.
Well, I mean, but it's a whole.
You know why?
Period from the lighthouse.
Yeah, but we can still measure how far is the sailboat from the lighthouse. Why?
Because a straight line is
Because
always the
it's a
smallest.
rectangle.
No. What I'm saying is that it could be any point on the lighthouse that you're measuring from, and it would still be from the lighthouse, and the distance is
Not true.
vary.
Not true. Okay, that's true. That's what I'm saying. This hypotenuse right here is the distance between the top of the lighthouse.
Yeah.
The-
But if you say you're measuring
but
from the
if-
lighthouse, you could be measuring from the top of the lighthouse.
Yeah,
or the
and that's
bottom
what
of
I'm
the
saying.
lighthouse, or
It's
the
going to
middle
say,
of the lighthouse.
if it doesn't say specifically, if it just says, how far is the lighthouse, then they're talking about bottom to bottom.
Mm.
And in this case, because the bottom, right, isn't listed, but we know that if I did draw a line right here, I'd make a rectangle, right, because this is a right angle. Therefore, if this is X, then the top line is, and that's kind of the logic behind it.
So that's
All right, let is Anna's problem. All right, what's the trig ratio?
25 divided by x.
Yeah, but what's the trig?
Sine.
Okay, sine is opposite over,
Adjacent.
nope,
Oh, hypotenuse.
and that's the hypotenuse. There's no number on it. So it's not sine,
Tangent.
it is tangent, opposite over adjacent. Okay, so we got opposite and adjacent, it's a tan one, and this is one of those ugly ones again. If you remember the pattern, great. If you don't remember the pattern, then you do some algebra. McKinley, one more time, what's the algebra?
You multiply x by both sides, get x tan 15, then divide tan 15 by 25.
Nope,
No, to 25 by tan 15.
Yep.
And you get your number. I
And you
will
get
type
your
that
number.
into my calculator. And you get 93.3.
and notice this is different. Notice, why was this one shorter? The other one was what, 716? Is that right?
Yes.
Why is this one way shorter? It's still the same height of the,
Because you're looking down.
Or no,
Well-
you're looking at the.
should make a difference whether I'm looking down or looking up. The distance is always the distance. So why is this one 93 and the previous one 716 meters?
The degree is
And why would that make a difference, common sense wise? As the closer the object gets, what's going to happen to that angle?
Gonna
and
disappear.
I get bigger.
So think about how tall is the I don't know, the ceiling here, like right there at the edge. So I'm standing right here. This angle up there, is this big or small?
Small.
And as I get closer, what happens to my arm? And no, I'm not trying to do some Nazi thing. What happened?
The angle is-
And it gets bigger and bigger and bigger and bigger and bigger. All right. So that's why. And by the way, it went from 2 degrees to 15 degrees. That's not that much, yet we lost, almost 600 meters of distance between them. What's the other way this question will ask? What's the way all trig will ask, at least the trig we've learned so far? You're either solving for a
Slide.
or a,
Angle.
so what's the other way this could be asked?
It'll ask what the angle of depression is.
It'll say, what is the angle of elevation or depression given some variable? So, Allie, this one's yours.
So you start with, so you look to the horizon from the sailboat first, which is the first line,
Okay,
and then you go up from there to create.
because this is an angle of elevation. We wouldn't do an angle of elevation from the, at least unless we were, I mean, I guess if we were at the bottom of the lighthouse, then we could have an angle of elevation to the top of the mast of the sailboat, but that's not the case here. So yeah, we're going to look to the horizon first and then up.
And then the angle of elevation is F.
Is unknown, theta, whatever,
And
right?
then the lighthouse is 25, and then the distance, which is the bottom, is 500.
And what would it read for the hypotenuse? What would the verbiage be? Like, yeah, I'm agreeing that that's 560, but if instead they were talking about this black line, the distance, what would it read? So 560 is the distance between the lighthouse and the sailboat. So the black line is the distance between what?
The sailboat in the top of the
That's what it's going to say. It might say something like a person on a sailboat sees their friend at the top of the lighthouse, something like that. And I don't know how you would measure that, but using some trig, they measure it, and it's 700 meters, something like that. Okay, so now what do we do?
So the tangent x equals 25 over 500.
That's the setup.
So then you would do the inverse
Do
tangent.
the inverse tangent. Do I really want you to write this? If you want to impress me, yes. Right? Well, what I'm really looking for is this part right here. Inverse tan of 25 over 560. Which is,
You can simplify that too.
yeah, and I could. I'm not sure that if you have a calculator, how that would speed things up, though.
2.5.
Okay. Before, when it was 700 meters away, what was the angle?
2.
And we just went up a half a degree, and we almost lost 200, 150 meters, right? That's how much these things change pretty quickly. As you get closer to the object, the angle of elevation or depression increases. What is that symmetric doing? It just keeps going backwards and forwards.
What?
Oh, the symmetric.
Oh.
But it's
He's
like
trying
the
to
fourth
get
time
out.
it's done that. And it's the
Good
same
try.
one. It's not like getting refilled or anything.
Maybe it's driven by someone who was at the bar.
All
last
right,
night.
Jack, since you didn't get one, this is yours. All right, this is too easy. Too easy. I need one that has, okay, here we go. Number 7.
Okay, at the bottom travels from the point A at the top of the hill, the point B at the bottom. Because the steepness of the hill varies, the angle of from A to B is only an approximate measure of the steepness. So it travels from A to B, the vertical descent AC. Oh, okay,
Tell me
so
what's right.
make a right triangle first.
Okay, I already did. That was easy.
Well, that's not really a right triangle.
So,
That's not even
Well-
a shape.
did you remember what it says? Because of the steepness hill varies, the angle of depression is an approximate measure
Okay.
of the
So-
average steepness.
So it's going to be 130 from A to B. So 130.
From A to B, so this is 130.
And the vertical descent AC is 50 meters.
I just showed
So you can figure out.
And what is it asking? What is the angle of depression? So where do you want me to put that X?
B.
Where are you starting from?
I can't figure out. Oh, wait. No, I can just do A. Then just put it at A. And then you can just do cosine. So you can just do inverse cosine 50 over 130.
And this is why you, like me, got this wrong in high school.
Why? Oh,
Because what do you actually have to draw first?
you have to draw the horizon line.
See what I mean? You're just as bad as me. Thank you. So that's actually what you got to draw first. And I suckered you into getting this one wrong. There is one time where it won't cause you any problem. That's when it was 45 degrees and 45 degrees. But any other time, you got to draw that first. All right. So that's 130. This is the angle of depression. And that's 50. Okay.
Okay.
So what's the trig?
So we can just do inverse sine 50 over 130.
Okay. And that gives you
22.6. So it's.
and the book says 23 degrees. That's A. How about B?
B.
Oh, never mind. That's an easy one. Never mind. I thought that was a different thing. All right, cool. And I'm just going to say, if you had left it the other way, what would you have done?
I probably would have gotten it wrong.
I know, but I'm saying, why would you have gotten it wrong? Because you would have done.
The opposite of it would have been the complement of it.
You would have done cosine.
Yeah. Right.
And welcome to my feeling like an idiot in high school. Because I would get this wrong, and I was like, I know this stuff. And I just didn't listen to the teacher said about go to horizon first. And it's really easy because they sucker you into this one because it looks like that should be the angle of depression. I still argue that that's the angle of depression. According to their definition, it's not. Yeah. Now you could say it's the complement.
It is the complement. So you could figure that out and then just 90 minus.
Yeah, you could do that. All right. Any questions on anything we did? Ben, questions?
No.
I don't know if you caught that last thing. Jack literally did the mistake that I made. Let me see if I can draw it for you. If you don't draw to the horizon, then you think where this X is. Can you see that, Ben?
Yeah.
You think that X is the angle of depression. It's not. It's actually this Y is the angle of depression. Because you have to draw to the horizon first and then look down for depression. Or if you do an angle of elevation, horizon first and then look up. So this is the actual one. And if you didn't, because this was 50 and the hypotenuse was 130, that's a big difference between doing cosine and doing the actual thing they wanted you to do here, which was sine. So don't make that mistake. Why did he walk in and put a calculator on my desk?
I don't know.
That was kind of weird. And it's not even my calculator.
You might think it's your calculator.
Well, I guess that's a reasonable decision. All right, Ben, that's all I got for you. You have anything?
No. Nothing related to math.
Well, give me something that's not related to math.
I discovered something on my calculator and I feel stupid that I haven't discovered it before.
What?
I feel like that is related to math.
Basically in the calculator, you can store up to 999 different 1,000 different file photos, each one being a drawing from the graphing section. You can recall those instantaneously in the code and it proves for some worthwhile jump scares. That's all I'm saying.
That's cool. That is cool.
Yeah, it also helps when when you're trying, like if you want to have several lines moving at once, you just recall the photos and in order, and it looks like several things are doing something when it's only just photos. So
That-
it proves
that
for
is
some
cool.
good animations as well.
I'll tell you something that I discovered over Christmas break that I've already forgotten and I have to rediscover. There is a
What?
way to pull up a fraction in like the fraction format, and I've already forgotten how to do it.
Just push alpha.
I know how to do that.
Alpha, yes, he is right. If you press alpha X, it gives you and there's one to do it with a mixed number too. How do you do that one?
Just
I thought there was one with a
just push alpha X, go back one, and then your thing.
Oh, okay, I got you. Did you know that, Ben?
Yeah.
Are you saying yeah because you don't want to say no?
No, I do know.
I didn't know that.
I mean, you don't really need to do that because when are you actually ever going to need that? You can simply
So
just
when
type
you
it in
start
using the
next
normal
year-
format.
When you start next year entering, well, maybe, yeah, no, you'll do it next year, Algebra 2 as well. When you start entering this really ugly function that's a big, long fraction, it's just easier than putting parentheses. So you can leave it in fraction form instead of writing the fraction as numerator divided by denominator. It just saves some keystrokes. So for instance, if the numerator was x squared plus 2x minus 3, and the denominator was x minus 4, it just saves some time. And I didn't know you could do that on this calculator.
Oh,
Now I do.
well. Good job. Good for you.
All right, Ben, I'll catch you later.
All right. Have a good day.
You as well. See ya.
See ya.